So and yeah, first of all, thank you for welcoming me again. I've spoken here a few times before, and this time we will talk about diffing firmware images. And yeah, here's the quick agenda. It's really just 2 points because you know the format is rather short, so we will have more time for discussion. I will briefly recap like what AMD PSP platforms are looking like, or now you could call them ASP platforms, whatever. We don't care too much right now here. And then I will talk a bit about the challenges in diffing different flash images. Well, think of firmware images. I'm just saying flash images because we typically use a SPI flash for x86 firmware. Um, yeah, including AMD. But yeah, how did it actually start? You already said it. You wrote me a message at some point and you said like, hey, yeah, I would be interested in having a tool for diffing. It would be great if it could like look at the different services, like, given two different firmware images. Let's see what, is actually implemented for the PSP. And I had already looked at AMD platforms, well, about a year earlier. Yeah, if it is possible. Yeah, I just omitted most of what you wrote, just focusing on this one particular part of the sentence here. Um, anyway, so yeah, I had already forked Romulan at some point, and yeah, that is mostly because people who know Fiedka, the project, um, it's a visualization tool and also editor for firmware. And I want to be able to essentially show everything that you find in a firmware image, and that would include PSP firmware. So what I started with was just UFI stuff initially. But yes, we all know it's today really just a fraction of what's actually in your firmware, right? Um, so yeah, I sat down at some point. So you wrote me like mid-September, and then in early October, we were at one of the nice CCC events here in Germany. So CCC being the Chaos Computer Club, and there is this one event called MRMCD, Meta Rhine Main Chaos Days, and we had a lot of fun hacking on stuff. And I sat down and said, well, let me then actually get started and implement this feature. And somewhere over here, you see a part of my laptop. Anyway, yeah, this is where we sat with our hackerspace, ChaosPod, and that is actually also where I implemented parts of what I'm going to show now. So yeah, about the PSP platforms, there is one tiny issue I need to start with, and that is there is actually not that much public official documentation. So if you look at AMD's website, they have this documentation hub. I put the links down here. There is a bunch of information, but unfortunately, there is not like, hey, this is how you would parse a firmware image, and this is what the components in there are, and here's how they work, and so on. That is unfortunately not what you find in there, but we're lucky. There are some people from AMD actually working on the core boot project, so we do have quite some documentation within core boot, and then also a bunch of code. And in that code, you see some semantics, like from reading it. Uh, oh, and Andrew would like to say something. Please go ahead.
Hello. Very quickly, I don't see it anywhere in this list, but recently some of the source code for PSP modules have been released. So whilst there may not be documentation, there is at least official parsing code for a bunch of them available somewhere.
That is excellent to know. I did not know that. So,
So it's part of the transparency. So basically, they writing a whole bunch of it in Rust and producing Rust. So then they're starting with the bits and pieces for the confidential computing stuff, so vendors can go and look and try and do reproducible builds or auditing and stuff like that. So the source code is available. It's not particularly well advertised.
mhm.
Yes, I think I might be talking about that link. That I recognize that link. So okay, it's there in the chat.
All right. Then I would say let's just go ahead here and let's later come back to this in the later discussions. maybe not in the Q&A here, but like way later, after all the talks we had. I guess there is quite a bunch to carve out then. Anyway, so yeah, that was frankly not the case. Like when I started looking at this stuff, and that was roughly, I don't know, I think 2022 June or something, or January. I don't know, middle or beginning of the year. I don't really recall. Anyway, so yeah, the other things I could look at were some parts that were implemented in Fiano. So Fiano being from the Linux boot project, like a giant toolkit and lots of packages written in Go for parsing and manipulating firmware. Then Immune have implemented a bunch of things. There is quite a lot to dive into, but it's a bunch of code. So yeah, it's quite hard to navigate if you haven't actually worked with that quite much. Then there is the so-called Converged Security Suite. Um, that one also contains a bunch of information again. That is mostly like focusing on like manifests and signature stuff and so on for security validation purposes. So it's a bit more of a narrow focus. Then we have a bunch of information in different forums, like the WinRate forum, which is now hosted by Level 1 Tech. Then we have the Dashrow community, of course. We're also going to hear a bit more about other aspects of the AMD platforms later. Then there is some reverse engineering efforts that had been done by Mimoya, for example, made MFT, Mimoya's firmware toolkit. We have the PSP reverse project, and then Platbox, a tool made by a company called IO Active, which have done some security evaluation and actually found quite some issues and posted them, reported them, and so on. And then what I forked is System 76, or Jeremy Soller's tool called Romulan. Yeah, the original repository is down here, and from there you will find my fork, or I will also have my link later. Well, and then also my own efforts on top of that. So yeah, over time I could also figure out a few things which are not necessarily implemented anywhere else so far, or they sort of became obvious when I looked at a few samples of like firmware images. I think I have like, I don't know, something in the, I don't know, 20 or 30 images, something like that. So yeah, just to briefly recap how that platform now actually works. So what I've sketched here is essentially like a very rough view on what the hardware looks like and what the boot flow looks like from a very, very high level perspective. So within the SoC here, we would have the so-called PSP, so that would be a few ARM cores. Then we have the x86 cores, which are typically used like SMP cores in a way, and there would be a mailbox interface between them. And what the PSP would actually do is it would actually start the whole platform, and the x86 would not yet be running, right? So the PSP itself would actually then initialize the DRAM, which is then used like by both the host operating system later and also whatever is running in the PSP, right? So there are actually some features which require that. Um, so when the PSP is done initializing, it would then verify the firmware. Well, that is optional. We will hear a bit more about that later. Using a feature called PSB. It's, I think, Platform Secure Boot or something, or PSP Secure Boot. No idea. Anyway, it's essentially like Intel Boot Guard, if you will. That would then let the x86 release, and it would continue running, and then you would have its own secure boot, whatever, again depending on the OEM or whatever vendor, and then finally you would have your host operating system running on sort of a virtual platform, if you will, because it gets like usually like UEFI and ACPI interfaces from the x86 firmware, and then also still the mailbox from the PSP would also be available, and so on. And now the interesting part is, and that is what we're going to look at, on your mainboard, you would have a SPI flash which contains the firmware for both sides, the PSP part and the x86 part. And to look at that in detail, let's zoom in a bit. So this is what your data in flash looks like. There is one thing here, which is called EFS in short, or embedded firmware structure. And that is, well, a bit richer than what I'm displaying here. But the interesting part that we're now looking at is there is a bunch of pointers. So as you can see here, there are different slots, and it's exactly those 6 actually. Not all of them have to be used, but they would point to something that you may want to call a directory. And I put BIOS here in quotes because we don't actually have that anymore nowadays, but it's just the name that is still being used for whatever x86 firmware may be. Now the thing is, these pointers actually already point to different sorts of directories, different kinds of directories. There are so-called, well, I call them immediate directories, so it's really just then a direct list of files, or it could be a combo directory that again points to other directories. More on that in a bit. Now, within those lists, there can be multiple references to the same directory. So we might want to deduplicate them. I haven't yet implemented that, but yeah, keep that in mind if you want to maybe contribute to my efforts. There may be multiple references to the same file. So you may now imagine there are also files in here, and they may just be lingering around anywhere in this flash here actually. It's a bit weird if you think about it, but then I guess it's just okay for its purpose because it's usually just read-only stuff. It's usually just written once by the OEM, and that's about it. There is some part where like settings or something can be persisted, but otherwise it's like mostly just static information. Oh, and binaries, of course. And then there are different variants of nesting things. Like one of those PSP directories, for example, may actually contain a so-called BIOS directory again, which seems a bit odd. And then there can be a second level of directories. Those are even called level 2 directories. So what does it now look like if we want to diff two images? Well, the obvious things we can actually look at are the different sizes, right? So I could look at 2 different images and say, hey, this here is coming from a flash part that is 16 megabytes, another one is 32 megabytes. Obviously different, but that's actually not too interesting for us, right? We're not about the sizes, we're about the contents. So we start looking at the EFS. In the EFS, we can see these 6 slots that I just mentioned earlier. Some of them may or may not be used on either side. So if we compare 2 images, I will refer to those as sides. So, left-hand side, right-hand side, or side like 1 and 2, whatever. They may then just target different platforms, right? So over time, AMD is releasing new processors, and the newer processors actually get, different sorts of firmware. So the slots in the EFS, they are for ranges of processor families. And then again, in the so-called combo directories, there is again a list which is then discriminating between different versions, like within a processor family. And that is where it gets a bit finicky. And as you may already imagine, like everyone building those directories a bit different actually poses a challenge to me for analyzing that stuff. Then there may be different components, like in each and every directory. Think of files actually. Um, you know, some may actually contain like additional services for whatever reason. It could be for I don't know, some sort of special features on a given mainboard, like another special piece of hardware on it, or it might be something that is only just internal, like a software feature. Anything is essentially possible. So like similar as in the UFI use case where if EDK2, vendors put all sorts of stuff in there. So yeah, it's not very trivial to compare 2 things. Um, then there is metadata for like some files. There is a header in the beginning which contains some information. I've seen some cases where there is no such metadata. I've seen some cases where there is different shapes of metadata. So, and the thing is, we don't have a specification for that. So I don't really know how to parse that stuff. I just looked at a bunch of samples and then came to my conclusions and implemented what I understood so far. Then we have signatures. So binaries are very often they're signed actually, so they can be verified, like I don't know, RSA signatures or something. they may actually differ. So if we just do, like, if we already know the semantics of EFS, we know the semantics of directories and so on, and now we get down to a certain binary, we may actually have the same binary in both images that we are comparing, but they may have different signatures. So if we just do a blind comparison, left and right, we would see, hey, there is a binary difference. Well, because of different certificates. Anyway, then different OEMs may have their own customizations. There is actually something in the, I think it was in the Corbett documents even, or I've seen it somewhere else, whatever. Anyway, so OEMs are free to, do some custom stuff. And then there's different ways to build directories, as I already mentioned. And I will just show like a bit of a simplified and stupid example now. So imagine this here. So we're looking at the EFS, right? So imagine this, like, I don't know, just a list of pointers. And that now points to two directories. One of them, let it be a just simple, what I call immediate directory. Let the other one be a so-called combo directory. Now the combo directory would then point again to other directories. And as I already said earlier, it actually happens that multiple entries may point to the same directory. So that's also shown in this example here. We have two platforms which are actually getting the same firmware here. So they would be like, closely enough related platforms in a way so that it actually works. And then there may be just a third platform supported by this very specific instance of firmware, and that again would have its own list of files and so on. All right, so that is already complicated enough. And believe me, if we go further in the details, it would get just even worse. So we will stay on a sort of high level here. And we will now just imagine we have two of those directories given, right? Let's say we have two images. Both of them have like an immediate directory pointed to by the same entry in the EFS. And now we take two of those directories. That is the next scenario now. So what can be compared? Imagine those directories may still look a bit different. So essentially, we're comparing two lists here, left-hand side and right-hand side. Now, those may have a different length, right? The number of entries, that may be different. And then I figure they're actually think of just kinds of entries which are actually candidates for comparison. So you may imagine on this side here, we have these entries A, B, D, and E. And then on the other side, we have B prime, C, D, E, and F. So the easy and obvious thing is, well, A is only on the left-hand side, right? But now B, D, and E, you will actually find them on the other side here. But here we have B prime. So imagine B prime, a variant of what is B on the other side. That might, for example, be a different version of the same binary. So those are now the common ones. I'm making a second list here. Now the common ones, well, I can mark them and say, hey, there is those two entries here, which are different. There is those two pairs of entries, which are respectively the same thing. Well, and of course, we have the third list, which is very simple. That is now only what you find on the left-hand side, on the right-hand side, sorry. So in the second list here. All right, so that is the strategy I implemented. And let me now show you a brief demo, and then we will head over to, our discussion. So for this demo, I prepared a few sets of pairs of images to compare. And let me actually start with this here. This is sort of simple enough, I would say. We're comparing images for X570. So X570 is like, let's say a common reference mainboard, if you will, like, roughly the same platforms. And now this here is two boards coming from different vendors, ASRock and Asus, even though they might be somehow related. Doesn't really matter in the details, but yeah, we will see those images. Well, they're, as you can imagine, they are not exactly the same, but you will see they are actually comparable. Let me actually pipe that into less here. So the first thing I'm always printing is, well, the rough summary of the EFS that I just described to you. You can ignore these other parts here. Now, the interesting entries for us are those 6. So those are the 6 pointers. 4 of them are for the BIOS or x86 firmware, and 2 of them are for the PSP firmware. And what I'm saying is, well, I'm comparing those pointers. So first of all, I can see, well, the pointers are a bit different. And if you look at this, you can already see the first challenge. So here you see something like in the range of FF, whatever, very, very high number. Now here you see something 00. And if you think about it, that would be like, I don't know how many gigabytes apart, right? But we're actually looking at very small files here. I think they're like both 16 or 32 megabytes or something. So actually rather small. And that is because, you know, those entries are actually referring to how they are mapped in the x86 context. So yeah, there's already a few questions in the chat. I will get back to those in a bit. Anyway, yeah, and this here is, I can treat those as the literal offset, like within the file now. So for those here, I had to actually map them back so that I would see, what is actually the position in the file. And well, simple enough. Here I would just omit the FF, and that would work. But I know that there is like different mappings for different like sizes of files and stuff. But yeah, let's ignore that for now. Anyway, so what I can do now is I can see what's actually in those directories. And what I'm writing here is comparing 2PSP versus 2PSP. That is one of those signatures that you will find to identify the kinds of directories. And what you see here now is this line. So this is telling us we're actually comparing 2 directories targeting the same platform. Yeah, I'm just also printing the offsets, but this is actually not the offset within the file here. I should actually rework that at some point to actually, have the file offsets always, because it's really hard to keep those mappings in mind and so on. Yeah, this is what you have literally, in the actual binary data that I'm parsing. Now, these here are actually offsets relative to that again. No, those are actually global offsets within the file. Sorry. Anyway, so yeah, we always have like size and offset here. And now we look at the kinds. So this kind of a file here is a public key. Then we have a PSP bootloader, we have SMU firmware, and so on. And all those names and essentially like all the high level stuff in the beginning was what was already in Romulan when I forked it. And then I kept extending it a bit over time. But yeah, that already gave me quite a boost. And then there is a few things which were not yet supported, which I could port over from knowledge that I found in PSP reverse. For example, is the version numbers here. Now, what you already see again is there is not always a version number. There are some things which just do not have a version number. And then there is things where I'm writing unversioned. Essentially, it means I couldn't find anything that looks like a version number. Let's put it that way. But it would actually have a version number in other cases. Like if I'm looking at the same kind of file in other firmware images, there might actually be a version. What you see here is the signatures. It's really just abbreviated, so you can quickly identify them. Good enough by those few bytes. Of course, the actual key size is much longer. So when I'm printing a key emoji here, it means there is a key, and the key with a padlock means it's a signature. And you can see this key is actually being used to assign this binary and this binary and this binary and so on. And down here you will find, hey, there is actually a different keys used. And now you may ask yourself, hey, where is the key material to verify those signatures? I frankly do not know. There may be some cases, I'm not sure if this is correct, where there is actually no signature. I think that is the case here. But yeah, full disclaimer, right? So it's mostly reverse engineering here and, building on top of other people's work. So yeah, there is always some uncertainty left here. Anyway, let me just continue with a few other things. I'm printing entries also here, which I could only find in the first directory, and then entries which I could only find in the second directory. And yeah, if you look at that, you will find that by those types of entries. So, and just one brief note here. There is like a main type and a subtype, if you will. I think it's called a bit different in the implementation and the code that I got. Anyway, yeah, I figured I actually need to look at those in detail in order to actually be able to compare them. So yeah, I must not confuse this and that one, for example. Right. And then it goes on. So yeah, there is now more and more entries. And here you can already see one example of a level 2 directory. So this again unfolds. And if you look at this, this only occurs in the second image that we're looking at. In the first image, there is no such subdirectory. But it might now be that we actually have something here, let's say this here, secure OS, and it might actually be the same thing as above. In this case, it is not. So we can see like here is a different version, but it might be the case for other things. And that is a bit of an issue now because, I have different nesting here, right? So this here is in a subdirectory. This is in the same higher level directory. It would be very finicky to always like go up and down and see what are actually candidates for comparison. So I'm really just being very, very simple here. I'm just looking at the very same platforms and the very same levels of directories for comparison. Do we have anything that looks similar? So we see version 1991 something here, not down there. So yeah, I guess not, just from a brief glance. But there is something that might be similar this year, PSP Trustlet. We have version 4.0. Well, here we have 5.7. That's a bit older than this one, right? So yeah, there might be some specific difference between those. Anyway, I'm ignoring that for now. Just one thing I wanted to mention because I just forgot that. I'm printing an X here. X means things are different, and then equals for where things are actually the same. And this is actually based on the binary comparison of the data itself that is behind those. Think of just pointers to files here. Yeah, we could now go on and on. So this was all PSP firmware now. There is also the BIOS directory. So what you would find the UEFI firmware in eventually, but also other stuff. Like there's this year the Agisa PSP customization block, and then there's a few other things. This year PSP output block. That's a bit weird. I think it's only a runtime thing in a way. Anyway, you can see it's size 0, so that doesn't really make much sense for me in here. But yeah, whatever. Some people may know. This year is the good old x86 firmware that you would see. And for the BIOS entries, there is something very special this year. This is where the code would then be remapped. Well, I think that's in the virtual memory space for the x86 or something. Yeah, but I'm not sure about the details here. Somebody else may chime in later. Yeah, and now scrolling down. Yeah, just another brief one maybe this year. So this year is from two, well,
Yeah, Daniel,
even remotely similar images. Yeah.
I will have to run to take care of kids for 10 minutes in 10 minutes. But I know that you feel free to show more examples. This is very cool. I'm just I don't know what was already there. What you added, is it like this icons for the detecting the signature of the module, and this diffing stuff is your development, or it was already before? It is your
exactly.
development.
So what I implemented here is the diffing itself, and then some additional metadata, and then also some additional file types which had not yet been implemented back then. So yeah, some knowledge that I found in coreboot, for example, or also in PSP reverse. That is what I added. Yeah, I just want to show two very brief examples now, and then I would like to head over to the discussion.
Sure.
Yeah. So here is an instance of things where I can't really meaningfully compare anything. So you just get two very, very giant lists of this is in the first image and this is in the second image. It's a lot to scroll through, and maybe with some more effort we can actually find something that actually tells us, hey, maybe we can actually still compare something. But yeah, I don't think so. Yeah, you can see here also, like, for whatever reason, there is one image or there is actually nothing in here. But then again, there is something where we can compare both sides, and that might actually be the case, for example, because it might be that the so-called BIOS directory would be nested down here. I don't know. We can actually have a brief look at that. Oh, look at that. So here we have a level 2 PSP directory and we have a recovery BIOS directory. So yeah, that is why it's not obvious how to compare those two. Anyway, just one brief example of weirdnesses I'm encountering here. And then in coreboot, we also have a tool that would create firmware images for you. I think it's called AMD FW tool or something. I forgot. Anyway, so yeah, that would also be able to create images that we can compare. So just very quickly, here is one instance where we have two entirely different platforms again. So you would get two big lists. And I want to show another instance where we just have two different kinds of structuring things. So this is really just for the same platform. This is now both Picasso. There is now one where we have immediate directories and one where we have combo directories. So that's an option in the coreboot tooling. And as you can see here, they're indeed a bit different. But I can't really meaningfully compare those, and that's why we once again get those lists here. So here you would see it says BIOS combo directory, and well, up here it does not. So this here is the immediate directory, and here you have a pointer again somewhere else. But that would actually be the same content as above here. So yeah, I would need to figure out something in order to compare those meaningfully. And with that, let's actually head over to a discussion round. And well, here's my thank you slide, and well, all the links, in order to follow me and find all the work I'm doing. And here is my fork of romulan. So yeah, if you compare that against the System76 branch, then you will see there is actually quite a bunch of stuff I've already put in there.